All right, so welcome back, everybody. For today, we're going to be covering notes 8.5 statistics. And with statistics in our SBAC packet, we're really taking it back. I mean, look at the words that are going to be showing up for today. Already here, I see the words mean, median, and mode. The last time you actually worked with mean, median, and mode is middle school. And so, yes, the SBAC is sometimes going to throw these questions at us, even though they're from the middle school days, right? So, statistics are numerical values used to summarize and compare sets of data. Two important types of statistics are measures of central tendency and measures of dispersion. Now, we're going to concentrate on the measures of central tendency. So, here's the definition of that. It says a measure of central tendency is a number used to represent the center or the middle of a set of data values. So, a lot of times in the news, when you hear, oh, we took a poll, we're trying to figure out what most people are thinking. Sometimes they'll use the average, sometimes they use the median. You really have to be careful and use the right data to represent, the right number to represent a big set of data. And so the three that we go with the most is we have the mean, which is the average value. Then, of course, we have what we call the median. And if you remember from the past, the median means to be the number right in the middle of the list. And of course, we have the mode. Now, the mode is the one that kind of repeats itself. And so as you're looking here, it says the word most. Now, one of the toughest things to do back in middle school was to figure out, okay, well, which one of these do I use? And try to tell them apart. But they all start with the letter M. So we actually give it like a different name, right? The mean means the average. And if you notice, look at the directions. To find the mean, so again, this is your reminder of back in your middle school days. When you do the mean, it means you're going to add together all the numbers in the list. And then once you add all the numbers in the list, then you're going to divide by the number of values. So if I have a list of 10 numbers, I'm going to add all 10 numbers and then I'll divide by 10. If I have a list of 7 numbers, then I'm going to add all 7 numbers, but then I'll divide by 7. So that was what the average or the mean represented. And then, of course, we have the median. Now, the median means to be the number right in the middle. So in order for me to find the number right in the middle, notice we have to start by putting the values in order. And so that's the key. We need to remember to put all of our lists in order from smallest to biggest. Then I'm just going to take the value that's right in the middle. Now, there is a little bit of a catch, though. You see, if you have 7 numbers, well, then it's going to be easy to find that one number right in the middle. But if you have 8 numbers, if you have an even number that you're going to be working with, then an even number of values in the list, the median becomes, look at that, you have to actually take an average of the 2 middle values. So only if you have an even amount of numbers in your list, you're going to add 2 numbers together, and then you're going to divide them by 2. You're going to take the average of the 2 middle numbers. That's what the median will be. And then finally, of course, we have the mode. Now, the mode is the one that happens the most. So here's the one that we care about, repetition. So we find the value that appears the most. See, that's simple. Find the value that appears the most. So that's why it's also good to put it in order, because then you can see that repetition. So it happens most frequently. Now, there's a little bit of a catch, because what if all the numbers are different? Then there is the possibility, if all numbers are different, and only if all numbers are different, if they're all different, then there is no mode. So it's okay to say that some data sets have no mode at all. It also does mention that if there are any with the same amount, then there's going to be more than one mode. So I can have none, or I can have more than one. So the mode was the very unique one there. But mean and median are the ones we use a lot when we're talking about data and data sets. And look, we could talk as much as we want about it. Let's put it into action here with this first problem. So, question number 1. Mr. Lopez priced 5 calculators. The prices are shown below. So we have 5 calculator prices here. Well, we already learned that if I'm going to work with this, it's probably a good idea to put these numbers in order. So first number on the list would be the 15. See, next number on the list would be the 30, then the 40, and then, of course, a 70 and another 70. So there we took a little bit of time just to make sure that all of our numbers were put in order. Now that they are, now we can start answering the question. Question number 1 said, well, what's the mode? Remember, when we're thinking about mode, we're thinking about the most or the one that repeated, right? The most. And if you look carefully, clearly the 70 was written twice, then the mode would be 70 for this question. The following question is asking about the median. Well, if they want me to find the median, they said, we'll put it in order. We did. And then they said, spot the number that's right in the middle. So if we're going to look for the number that's right in the middle, well, let's see. Looks like the 40 would be right in the middle. And how do I know it's in the middle? I have two numbers on this side. I have two numbers on this side. Definitely the middle. So nice and simple problem there. And then they said, well, let's find the mean. Well, according to what we just reviewed earlier, to find the mean, all I have to do is I have to add all the numbers up. So I'm going to add the 15, the 30, the 40, and the two 70s together. And then at the end of it all, I will divide everything by 5. Why? Because there's 5 numbers in my list. So when I take a calculator, use a calculator very carefully here, I add these numbers up and I get 225 divided by 5. So that means that the mean value would be 45. That would be the average price of that list of calculators up here. So notice the difference. That's why there's a lot of different values for measures of central tendency. But again, I wouldn't use the 70, the mode, to represent this entire list, because that was kind of at the high end. Maybe the average, right, the mean or the median might be a little closer to representing all that data. Now, looking at number 2. Now, number 2 brings in a special issue with the median. Here, the median worked out. It was right in the middle. We had one number that was right in the middle. But when you look at number 2, it says Robert priced 6 shoes. The prices are shown below. What is the median? All right, well, we said if you're going to do a median, you should put all this list in order. So 15 would be first, 20 would be second, there's a 25, there's two 30s, and there's a 35. I like underlining. It just reminds me that I make sure that I've used every number. But there it is. We have it in order. But when we ask, what is the median? What's the number right in the middle? Well, we kind of have to be careful. Look, there's one on this end. Now 2, but there is no middle. There's actually 2 numbers that involve the middle. So that's why the direction said that when you're working with the median and you have an even amount of values, then you need to take these 2 numbers, the 25 and the 30, add them up, and of course, divide by 2. So 55 divided by 2 gives me a value of 27.5, and that would be the median for this problem. So again, the median works nicely. If it's an odd amount, then you're going to get just one number. But when you have an even amount of values, we have to go with the 2 middle, add them up, and then divide by 2. Now, that was the 3 concepts of mean, median, and mode. So now we can use that information to do other things in stats. So here we go. Look at over here. We have what we call a histogram, or histogram shapes. We're going to start off with that. But a histogram is just another way of displaying your information. Now, it says the skew is in the direction of the tail. The median is more appropriate for pictures that look like this. All right, so let's try to understand what they're saying. If you have data that is skewed, and when you have skewed data, look at what it means. It means you have more information leaning in one direction. A lot of our data is leaning in one direction. So when the data leans in one direction, they're letting you know that the median, whatever answer that is a better representation for what we're seeing here for that data set. But again, like we just mentioned, you're only going to use the median if your data leans. right? If it's leaning heavily, if the data leans heavily in one direction or on one side. So whenever this happens, right, we draw a histogram, and then all of a sudden, most of my data is leaning heavily on one side or the other, right, depending, then that's when the median is the best choice to represent the data. But if you look at the bottom, look at the data here. When I look at the data set for these, it's very even. Look, it's very balanced. Almost think of it, look, we call this a bell curve here. Look, think of it as a parabola almost, right? It's very symmetrical. And sometimes it's a little bit off, but this would have more symmetry than these that lean heavily on one side. And then look at this one. This one is completely uniform. So whenever you have data like this, and with this data is balanced. I like using that word. So we have a balanced set of data. It's not like it's leaning in one direction over here. But when you have a balanced set of data, that's when working with the mean becomes a better representation of this information. So if your data, like I said, is very symmetrical, aka it's balanced, the mean would be the better number to represent all data. Over here, the median would be a better representation of that entire data as well. So we're going to practice how to create our own histograms so that we get a better understanding of how to read them in case the SBAC wants us to read a histogram. So here we go. And we're going to bring this up once again. All right, so a student has the following scores for the first 8 Algebra 1 unit tests. So the student got a 95, a 41, maybe they had an off day, right? A 91, a 93, a 97, 75, 88, and 89. So there's 8 numbers on this list. They said, find me the mean, the mode, and the median. Then you're going to create a histogram. All right, well, the first thing I'm going to do is I'm going to put this data in order. So that's the first thing I want to do. I'm going to put all of this data right here in order. All right, so here we go. Let's see. The first number on the list, smallest number would be 41. So there's my 41. Next number on the list would be 75, 88, 89. Let's see, I've used this, and this. 91, 93, 95, and 97. All right, so there's my data. It's in order. Let me double check, make sure I have all 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have all 8. Just want to make sure that you didn't leave one out. Now, what they asked for was, they said, give me the mean, the median, and the mode. All right, we don't have to do it in that order. I'm going to go with the easiest one. I'm going with the mode. I'm going to ask you about that one first. So if I'm looking at the mode, this is the number that repeats the most. And if you notice, there is no repetition of any number, which is why my answer for mode is there's none. Remember, that counts as a valid answer here. If there's no number that repeats, then we have no mode. All right, next question. Let's do the median. Now, the median, we said, is the number that's right in the middle. All right, well, let's look for it here. Let's look carefully. Well, there's 8 numbers. If there's 8 numbers, there really is no middle. That means I'm going to have 2 numbers in the middle. So that would be these 2 right here. And how do I know these 2 are in the middle? I have 3 on this side, and I have 3 on this side. That's how we know that's the middle. All right, so let's set up our median. I'm going to go 89 plus 91, and then divide it by 2. So in this case, when I do the math with my calculator, my median becomes 90. All right, so we have a median now. And the last thing they wanted from me was the mean. So I saved that one till the end. Now, we don't have a lot of space to do all the addition, but we can use a calculator. I know we have 8 numbers, so I'm going to divide by 8. So right now with my calculator, I'm going to add 41, the 75, the 88. I'm going to add every number on this list on my calculator very carefully. And when I do that addition, I get an answer of 669. But I still need to divide, so I'll let the calculator do that for me too. And with a little bit of rounding, we get a mean of 83.6. So there's my mean. Okay, they wanted these three things. We now have it. So now we're going to take a moment and actually do a little bit of a tally first so that that'll help me figure out how to draw my histogram. So here's how we do this. How many numbers do I have between 40 and 49? Just the 41, so just one. How many numbers do I have between 50 and 59? None. 60 to 69? None. 70 to 79, well, I've had the 75, and that's it. So just one again. I keep looking. 80 to 89, so I have 1, 2, all right, just 2. And then 90 to 99, I have 1, 2, 3, I've got 4 of them. Remember, this is just a tally mark, nothing else. This is what's going to matter for us. Okay, so from the looks of it, they were kind of breaking down the numbers into groups of 10. So when I create my histogram, I have to zoom out a little here so we can see it. So I'm going to create my histogram down here. And because they were going by tens, then that's what I'm going to do down at the bottom. So there's my 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so just enough space there for all of them. All right, so here we go. First one, between 40 and 49. So after the 40 and before the 50. So we're talking about right here. I only had one number there. Then I can only color in one block, one little square. That's between the 40 and the 50, between 40 and 49. The next block that I have available here doesn't come in until 70. So between 70 and 79, I'm just going to color in one space. So 70 to 79 would be in here. So we color in one spot. Between the 80 and the 89, it says, well, give me 2 spots. All right, so here's 80 to 89. Then I would do 2 spots right here. And finally, from 90 to 99, so in this block here, we're going to color 4 of them, it says. So we're going to go with 4 here. And just like that, we have officially created our first histogram in many years. Like I said, we haven't done this stuff since middle school. So we have our histogram. Now the question is, which data, which measure of central tendency officially would best represent the data that we have here? Well, we know it's not the mode. We know it's between these two. But remember what it said above. They're asking, which measure of center do you think reflects the student's understanding of Algebra 2, the mean or the median? Well, remember, when it leans heavily on one side, this isn't balanced. This is leaning towards the right over here. Then it said on top that the median is the best way to describe this data. So the median would be that 90. That's the best number that can be used to represent this data set. Again, if it leans heavily in one direction, that's when the median kicks in. If it were well balanced, then the mean would take over. All right, let's try this again. Flip the page. Once you're ready there, flip the page. All right, here we go. We're going to try it one more time, but this time, not as many restrictions. So notice, they didn't tell me what to group them into. So that has to come from us. The ages of 13 computers in the office are recorded in years. 2, 3, 1, 9. You see the list. Find the mean and the median. Then create the histogram. Okay. They didn't ask for the mode this time, and that's fine. So I need to create this list. I'm going to use this line up here. I've got a 1, a 1. All right, 2 ones. I've got a 2, a 2. All right, 2 of those. A 3, just 2 of those as well. I've got a 4, a 4, a 4, so 3 of those. Let's see what's left here. The 5, I've got a 5. Got a 7. I've got a 9. And there's that 16, a computer that's 16 years old. Not sure why they're keeping that at this point, right? So here's my list of numbers. Now, they did ask for the mean and the median. All right, let's do that now. And we have space on top, so we're going to do it up here. So I'm going to go with the mean. Now remember, when you're doing the mean, all you have to do is add up all your numbers. So I don't want to write them again. I'm going to put this in a calculator, just play it safe. But I'm going to add the 1, the 1, the 2, and so forth and so forth. And if I were to add all of these numbers up here, I would get an answer of 61. And then, because there was 13 numbers, I would divide that by 13. So then my mean for this problem, 61 divided by 13, is roughly about 4.7. So there's the mean. But they also wanted me to figure out what the median is. Because remember, these are the two measures of central tendency that usually help us describe data. So the median is the number that's right in the middle. All right, well, let's find out who's right in the middle. Got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There it is. Look at that, right in the middle. Because I have 6 numbers on this side, 6 numbers on this side. Then there's my median. My median is the number 4. So that worked out, right? Because we don't have 2 numbers to look at. We only have 1 to look at there. All right. So now let's break this thing down. I need to do some tally marks, but notice I have no breakdown of any kind. Now, my numbers do go up to 16, but the rest of the numbers are very close to each other and kind of small. So, you know what? Let's go with groups of 3. So 1 to 3. So I'm going to go multiples of 3. 1 to 3. So that means 4 to 6. That's the next multiple. 7 to 9. 10 to 12. 13 to 15. And there it is, 16 to 18. So look, that kind of worked out perfectly. We went with groups of 3, and we were able to fill out the entire thing. We don't want to have too many groups. We don't want to have too little of an amount. So let's keep track now. How many numbers between 1 and 3? You see we got 1, 2, 3, 4, 5, and then 6. All right, so we got 6 numbers there. How many between 4 and 6? We've got 1, 2, 3, 4 of them. Okay. So how many numbers between 7 and 9? We've got 1, 2. And then after that, all we have is a 16 left. So I'm going to put a little tally mark right there. All right, so here we go. We're ready. Now remember, we went with multiples of 3. So because I'm going with multiples of 3, we're going to start with 3, 6, 9, 12, 15, and 18. That was the last multiple of 3 right there that we have. See, we're kind of using these outside numbers here on the right side. We're using those. All right, so here we go. Our histogram here. So between 1 and 3, so this first little block, we're going to color in 6 of them. Okay, so we got 6 of those in that group, in that data group. Then it says 4 of them between 4 and 6, so that would be here. So 4 of them. Okay, we got 4 blocks there. Between 7 and 9, we only have 2, so here's the 6. So between 6 and 9, we have 2 blocks. And then finally, we do have 1 more, but that's all the way to 16 and 18, so that would be right before the 18 over here. A little space for it, but way out there. So there's our histogram. The question remains, though, out of all this data, right, out of all this list of numbers, which number best represents this data? Is it the 4.7 or the 4? Well, when you look at the data, it is heavily, right? It's heavily leaning towards the left. And when you lean in one direction, we already said the median is the best number to represent that data. And so the median for this problem would be a 4. And that's the best number that represents all the data sets the data set that we saw. Now, on the SBAC, maybe you're not going to have to create a big old histogram like we did here and do all of that work just for one little question. This is what the question might look like on the SBAC. So they give you a histogram. What they want to make sure is that you know how to read these things. So the histogram below shows the heights of the black cherry trees. the heights of the black cherry trees, there they are. Those are the heights. And the frequency means how many of them we have. For instance, between the height of 60 and 65, notice there's 3 of them, right? Between the 2 and the 4, so we're going to go with 3. For 65 to 70, we know there's 3 of them. Between 70 and 75, well, we go this way. We know there's 8 in this group. For this rectangle, clearly there's 10 of them that measure between 75 and 80. For this part of the rectangle, looks like we're right in the middle again, so 5. And then this one, it's close enough to the 2. We're going to say 2. It doesn't look like it's right in the middle, so we can't call it a 1. So we now know how many of each height or each range in height we have. But look at the question. The question says, how many black cherry trees are less than 80 feet tall? Well, if they want less than 80 feet, well, here's the 80. So the cutoff is right here. And because they said less than 80, then I'm going this way. And if that's the case, in order for me to find out how many trees there are that are less than 80 feet, well, I already have all my numbers, so this makes it easier. I got 3 of these, 3 of those, 8 of those, and 10 of those for a grand total of 24 trees that are less than 80 feet. That's just me showing knowledge that we know how to read a histogram. So that's why a lot of the times this is what the SBAC question looks like sometimes. All right. Well, now that you've seen us create a histogram and read a histogram, we're going to pause the video so that you can try number 6 and number 7 right here, right off to the side, where you're going to create your own histogram again. And yes, try to create some sort of range for yourself. You don't want too many. You don't want too little either. Create a range, draw it, and then try number 7 as well. So let's pause the video for a moment so that you can try it out, and then we'll come back and check your answer. All right, now that you've had a chance to work on these 2 problems, here we go. Let's double check your answer. All right, so the first thing you needed to do was write this list in order. All right, let's see. First number would be 5. See, after the 5, we would go 8 and 8, it looks like. So 8 and 8. After the 8, we have a 9. I saw a 10. After that, we're going with the 13. And then we have a 16 and 18. And careful, look how they snuck that 19 way out in the front. A 19 and then the 20. Remember, it says there's 10 numbers here. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay, we're good. But they did ask me to do one thing. They said, give me the mean and give me the median. All right, let's go with the mean first. If we do the mean, we already mentioned that in order to do the mean, all I have to do is add all these numbers up together. So I'm going to let the calculator do that for me very carefully there. And when I add all these numbers together, I get 126. And because there's 10 numbers on my list, I'm going to divide by 10. And so my answer is 12.6. There's my mean. Now, they also wanted me to figure out the median. So if I'm going to find the median, then I'm looking for the number right in the middle. But there's an issue, right? Even though they're asking for the number right in the middle, we have 10 numbers in my list. So the numbers right in the middle are actually these 2. See, I have 4 numbers over here. I have 4 numbers over here. So now we know there's 2 numbers in the middle. So just don't forget, when you do the median, you're supposed to take those 2 numbers, the 10 and the 13, add them up and divide by 2. So once we do that, we get an answer of 11.5. So we're going to find out which data set will make this a little bit easier. Which measure of central tendency will represent this data a little bit better for us. But that's why the histogram is going to help us make that decision. So here we go. Now, I do see that my list goes all the way up to 20. Again, I don't want to have too many boxes, so I don't want to go by 2s. That would be way too many of these. If it's a 20, I'm going to try by 4. So 1 to 4, 5 to 8, right? 8 times 2. 9 to 12, 13 to 16, and then 17 to 20. Okay, we got an extra one left over, but not bad. That's enough right there. We just don't want to have too little or too many. All right, so let's do a tally. Between 1 and 4, none, actually. Between 5 and 8, 1, 2, 3 of them. We've got 3 of them. Between 9 and 12, well, we have 2. Between 13 and 16, 1, 2, we've got 2 of them. And then 17 to 20, 18, 19, 20. So we have 3 of those, so 3. All right, and remember, because we went in groups of 4 to create this tally mark and frequency list, so I don't need that list anymore. I have everything I need right here. Well, we said we went by 4s, so 4, 8, 12, 16, 20. That's a good amount right there. And so now let's bring in the colors. Between 1 and 4, nothing. So I'm not going to color anything in here. Between 5 and 8, I'm going with 3 spaces. So here we go, 3 spaces right there. 9 through 12, only 2. So here we go, just 2 for the next one. 13 to 16, just 2 again. And then finally, for the last one, they said we had 3 numbers, 3 pieces of data in this region. Now, by looking at it, remember, we have to make the decision. Is it leaning heavily in one direction, or is it very symmetrical? Is it balanced out? This one is pretty balanced out. Look, it's almost like it's a parabola right here, and a parabola is very symmetrical. So then, because it is balanced out, we're not going to go with median. We finally get to talk about the mean that will represent all this data, and we already had it at the top. So 12.6 would be a great number to represent this data set. All right. And last question on this page. Let's see. This is the other one you were supposed to do. The histogram below shows the ages of people at a 50th birthday party. The question at the bottom says, how many people are 60 years or older? All right. Well, they said 60 years or older. There's the 60. There's the cutoff. And they said older. Well, then we're looking at everything on this side. Again, you just have to read a question very carefully. Now, that means I'm going to take this rectangle, which represents 3 people, this rectangle, which is just 1 person, this rectangle, which is also just 1 person. So how many people were there that were 60 years old or older? Well, 5, right? 3 plus 1 plus 1, just 5 people that were 60 years or older. All right. Again, it's all about just reading a question carefully. You don't rush through these easy ones. All right, so that brings us to the last page of the day here, where we're going to talk about a box whisker plot. Again, something that's been years, right? You haven't talked about this thing in years now. So last time you did this was middle school. Now, the copy wasn't the greatest, so we are going to add a couple things that the copy is missing here. So a box whisker plot organizes data values into 4 groups, and that's the key right there, everybody. We have to understand that a box whisker plot is breaking things down into 4s. Now, the data that you're looking at and the data that they put here, it actually has nothing to do with this. This is just a number line. This is the data we're looking at. That's the data that's being represented in that box whisker plot. So let's start from the beginning, though. It says the median is 60 plus 70. So it does need this line. Notice it's missing the fraction line. So they're giving us a median. Now notice where this median is located. The median is 65. And check it out. Look where it shows up in your box whisker plot. Right there. There's the 65. So in the box whisker plot, they're letting you know that this is actually the halfway point. So that means if there was 100 people that they did a little survey for, 50 of them would be over here. The other 50 would be on this side with their data set. But that's what we're looking at. If 50 people took a test, let's say, if 100 people took a test, half of them are over here, the other half belong on this side. That's what the median is representing, to be right in the middle. And maybe that was their middle score. Now, once you do that, then we look at the other side. See right here, they call it the upper half. Well, remember, this is half of everybody that was surveyed or took a test, whatever it is. And even here, they're highlighting the number 78. The number 78 is what they call the upper quartile. Well, what you have to understand is, look where it's located. It's the middle. So the upper quartile represents the median, not of the whole thing, but the middle of just the upper half. And look at where that 78 shows up. Shows up right here. Again, not the greatest copy there, but 78 is right there. So now, not only do I have 50 people on this side, that 50 just got cut in half again, because that's what a median is. And the box whisker plot was all about cutting things in half, all about the median. In fact, the same thing happens on the other side. If you look carefully, we have the lower half. And when you have the lower half, look at the number they're highlighting, the 42.5. That's what they call the lower quartile. Okay, that's great. But the lower quartile shows up right here. There's that 42.5. Again, what does this number represent? It's the middle. It's the median or the middle of the lower half. Now, are you going to be expected to remember every single one of these new words maybe for you because you forgot them from before? Not at all. You're not going to have to worry about that. The only thing you need to remember is there are 4 groups here. And if you don't see it, look, it's right here, group 1. So we have group number 1, group number 2, group number 3, and group number 4. A box whisker plot is breaking down all your data into 4 groups. So if you were thinking percents, look, here's the breakdown. It goes from here to here. See, there's your 4 groups. This would be 25% of the group, another 25%, 25%, and 25%. And we have to say 25% because it's a quarter. We broke everything down into groups of 4. Now, for instance, if somebody had been taking a test and this is all their data for a test, it means that the lowest score somebody got was 35. That's the lowest somebody got. The highest score somebody got was 100. See, so that's what these 2 points represent. The lowest data point, the biggest data point. But whatever it is, we broke it down into 4 groups. So if you're going to remember something about this, here's really all you need to know. Here's all you need to, I hopefully remember in case this question pops up on the SBAC. All right, so here it is, the big note for a box plot. Okay, so as soon as you see one of these things show up, and it's not going to have all this craziness, it's just going to have this picture. But when you see a box plot, here's the only thought you need to remember. Divide the data set by 4. If you can remember to do that, I think you'll be okay and you'll be able to answer this question without any hesitation. Remember, the group is broken down into 4 groups. Don't worry about the percentage, right? 25, 25, 25, whatever. That just means 4 groups. So let's look at an example where we use this concept. It's the only one we have, but it's good enough. So it says, the box plot represents the score of 200 students on last semester's English final. So understand one thing. We have a group of kids that fall in here, in that group. We have a group of kids that falls in this group. We have another group of kids that falls in this one. And then we have one more group of kids that fall in this one over here. So we have 4 groups. That's a small little group. That's fine. But remember, here's what you need to do. As soon as you see that this is a box plot, take that 200 and automatically divide it by 4. And 200 divided by 4 is 50. Now let me show you what we're going to do with that number and how this is going to make this problem very simple. All of these colors represent a chunk of the 200 kids. Remember what we said. That's why we divided it by 4. How many kids fall in the green group? 50. Don't take that, not 25, that's percent. I'm talking actual kids. 50 kids fall in that group. How many kids fall in that pink group? 50. You have to understand, this isn't going to change. Every group has to be the same amount. There's 50 kids in this group, and in that tiny little group, guess what? Still 50. Every group of 4 right here, right? There's 4 groups, I mean. Every single group is automatically 50 because we divided the 200 by 4. If it had been 80 kids, I would divide that by 4. What is that, 20? I would have put 20, 20, 20, 20. We're talking about actual kids in each group. So now look at how we're going to use this. Question number 1. What is the highest score? Don't look here, look up here. This is the very last point, and look at that right there. The highest score, 95. That's the highest score that somebody got. Don't look at the numbers here. Look up here. That's the last point. Next question says, well, what was the lowest score? Okay, well, that's the lowest point, which means the lowest score that somebody got on the test was 30. Okay, so there it is. Following question. Let me move this up just a little here. We don't need all of that anymore. This is good enough. Approximately, what would be the median score for the students? Well, that means the middle of the entire group. Remember, don't go in the middle between 30 and 95. No. A box plot already told you what the median is. This is the median. Why? Because there's 100 kids on this side and there's 100 kids on this side. This right here is the median for the entire group. So the median there would be 70. Remember, it means to be in the middle. That's why I keep telling you, don't look here, you're looking up here. You got 50-50 over here, 50-50 over here, then this is right in the middle. The next question says, well, approximately how many students scored below 70? All right, well, here's 70. And if they want to score below 70, then I'm going this way. Well, look, that's 50, another 50. Well, then 100 kids, because 50 plus 50 is 100 kids, scored below 70. That's why it was important that you divide by 4 and get those numbers in there. I don't have to zoom out a little, but look at the next question. Approximately how many students scored? They said between 30 and 90. All right, well, 30 and 90. Well, let's look at our list here. 30 all the way to 90. That's the cutoff. That's where 90 is. Well, look at all the numbers I just went by. I went by a 50, another 50. Then how many kids scored between 30 and 90? Then we're looking at 150 kids. That's the answer right there. And then the last question, I'm going to have to bring it back down in a bit. What is the lowest score to be considered in the top 25? They're saying in the top group. To be in the top group, what's the lowest score you could get? Well, look carefully here. If I'm in the top group, that's this last group right here. They were scoring, the highest was 95, but what's the lowest mark? See, that's where we're looking at the 90 right there. That's the lowest mark for this top group. So they said, what is the lowest score to be considered in the top 25? 90. Again, we just have to know how to read box plots. We won't have to draw them, but we have to know how to read them. But that's why if you can just start dividing by 4, whatever the total, right, the data set is, divide it by 4 and get those numbers in there. It's going to make the problem a little bit easier to answer. And then the last thing we have to cover for today and from your middle school days is this concept of probability. So how do you find probability of an event? It's very simple. Probability, for any gamblers out there, we go with a fraction, of course. And the probability is basically the events, right? All the possible events that can occur there, divided by the total outcomes. So we're going to start you off with two basic questions. I don't think I've ever seen these on the SBAC, but it's just to get the idea across. Okay, so probability is events that are possible, right? The event we're trying to create or get, and then the total outcomes. So here we have a spinner. And when you look at the spinner, it has 8 numbers on it. So when I flick this thing and it starts to spin around, it can land on any of the 8. So now I know that my total for this one is 8. Same thing for that bottom one. I'm just going to write it already. But the total is 8. I can land on any of those 8. So now let me read the question. If you spin the spinner, what is the probability of spinning a 3? So the probability that I spin the number 3. Well, first of all, it can land on any of the 8. So that's my total. That would be my 8 at the bottom. And then how many of them are actually a 3? Well, out of all those 8, only one of them is a 3. So I have a 1 in 8 chance of getting that 3 when I spin. Now, in case SBAC asks for a percentage, which who knows, but if this is my fraction, all I do is 1 divided by 8, which is 0.125. And then just remember, to turn something back into a percentage, you always move twice. So that's why this right here would be 12.5%. So if you're a gambler, the odds are against you, right? You have a very low chance of getting that. Not a good bet. Now, let's try it again. For number 11, the total is still the same. But they said, what is the probability of spinning either a 7 or an 8? Well, the probability of a 7 or an 8. So now I have 2 options, right? The total is still the same. It's out of 8 numbers. But if I'm going to spin the 7 or the 8, look at that. I have 2 spots that I can land in. So then it's 2 out of 8, which of course we can reduce to 1 out of 4. So that's my probability. I have a 1 in 4 chance of landing on one of those 2 numbers. Now, again, if they ask for a percentage, you would turn that into a decimal, move it twice. So you got a 25% chance of landing on those 2 numbers. But again, this would be fine. Even this as an answer would be acceptable on the SBAC as well. Still, for gamblers, yeah, the odds are against you. This is what you might see on the SBAC, and chances are it could be. Who knows, right? Albert has 8 red marbles, 5 green marbles, and 9 white marbles on the floor. Why on the floor? And I don't know. It's not safe. So look, let's find a total. For me to find the total, all I have to do is add these 3 numbers together. And 8 plus 5 plus 9, that's 22 marbles. So he has 22 marbles on the floor. Now, his cat came along and batted just 1 marble under the seat. What is the probability that it was a green one? Well, think about it. I have 22 marbles total. And when it comes to green ones, I only had 5 of them. So the probability that the cat hit one of the green ones is, well, I have 5 greens only, and it's out of 22 marbles that were there. And just like that, there's my answer. There's a 5 in 22 chance that this would happen. And again, if you were turning it into a decimal, you just divide 5 by 22, which is 0.227. So we're looking at a 22.7% chance that it would happen. Again, this would be a valid answer, unless they really ask for a percentage, but I think they just want the fraction. 2 more to go. Now, in the next one, it says Nico has 2 purple marbles, 2 blue marbles, and 4 white marbles. So 2 purple, 2 blue, 4 white. All right, so the total would be 2, 2, 4. So that's just 8 marbles in a bag. So a little safer. They're in the bag. He pulls out a white marble and he doesn't replace it back in the bag. So keep in mind, for white marbles, we had 4 of them. But Nico did something here. He already took out, right? He took out a white one. So if he took out a white one, notice that changes a couple things. My total is not an 8 because he didn't replace it. He did not replace it back in the bag. So if he didn't put it back, this is not my total anymore. My total is now 7. And because he didn't put the white one back, the white one, now there's only 3. So we do have to keep track of that. The fact that he did not put it back. Now, why was that not an issue over here? Because they never took out a marble to begin with. It was the very first marble that we worked with. In this question, look at what it says. What is the probability of him drawing another white marble? So you see, this situation is happening not because he took out one marble, because they're asking about a second white marble. And so my probability, I'm not going to use the 8 for my total. Remember, he took one out already and never put it back. So my total is now 7. And because they said it's another white one, well, I'm not going to go with the 4. I now have to go with the 3 because that's all I had left. But again, this situation only happened because he didn't take out one marble. He ended up taking out 2 of them. And he never put the first one back. All right, we're not going to worry about the percentage there. That was just for review. So let's do this last one. So Mario has 8 red marbles, 3 green marbles, and 9 white marbles on the floor. Okay, so let's talk total again. So the total amount of marbles, 8, 3, and 9, that's 20 marbles. His bird came along and batted one marble under the seat. What is the probability that it was not green? Well, first of all, let's talk about green then. If it's green, we know there was 3 of them. Now remember, do I need to subtract anything? No. They only dealt with 1 marble. This problem, they took one out and then took a second one out. That's not what's happening here. So I don't need to do this, oh, I got to take one less. No, that doesn't work for this. So then for the total is 20, there's 3 greens. The question was, what's the probability of not green? Well then, if we're going to deal with something that is not green, then here we go. What was the total? There was 20 marbles out there. But how many of them are green? Well, 3 of them. So how many of them are not green? 17. And just like that, we have our probability. There's a 17 out of 20 chance that the bird knocked out a non-green marble. Now, with that said, you have your assignment for today, homework 8.5. Remember, before you leave, you should be dropping off 8.4 from the other day, but try to see if you can get both of them done, and that way you have nothing to worry about for this long weekend. All right, everybody, have a wonderful day and enjoy your weekend.